Hello, my followers. Good evening, good afternoon, good morning, where you are, depending on your location. Um, Today, you can see this is a gasoline generator dismantle. If you look at here, you will see a lot of different components. Okay, let me take it by one after the other. You can see this is my frame, already structure frame. This is my casing. This is my stator coil. This is my armature. This is my charger. This is my 12-volt battery. This is my charger. This is my cover. This is my DC motor. You can see my capacitor. So um, today I want to demonstrate because there is a lot of question which have been through by my followers, subscribers. So I should show them how I did my setup. So it is very simple if you understand it. So today I want to I want to like reverse my ratio which I've already did before, so that for those that didn't follow up, so that you guys will understand it. So I will take it one after the other. I will take it one after the other. So now this is my stator coil. You can see this is my stator coil. Okay. So now this is my coupling. I made it locally. I sourced the because sometimes if you do it shaft to shaft connection, if you didn't do it perfect, the system will be vibrating, and it will take a lot of energy. It will consume much energy. So I did it this way. Even though there is any vibration or there is any error, it will occur in this belt. Okay, let me show you what I use as this belt. So you can see this is a fan belt. You can see it on automobile, like in motor car engine. So you can see. So I cut it, I measure it and cut it. So it has a three line here. So you guys can see. So it's very simple. Use this 1 mm angle iron. You have to cut here. Then you can see how I did. So any shaft of the dimension you want to put here, then you have to weld it, then drill it, open a hole so that it will be like this. You can see. If you like, you can double the belt. You can double the belt, or you can make it single. So for those that asking me how I do my coupling, so it's very simple. Just get a angle rod, angle iron. Just can see, just cut here. Then depend on your dimension. Then you can see I already did this, but it is not the same size with this shaft of this motor. This shaft of this motor is I think 8 mm. So you can see it. When I put the shaft here, I will tight the system. So now, if I want to couple it, this is the way. So you can see, make sure that this enter here. You can see it. So make sure it enter there, so that it will fit very well. Make sure that it enter here. You can see. Make sure it enter very well. Okay, let me this one now. I've already. So now this is my rotor. This is my rotor. In the previous test, um, this is the original magnet of this rotor. This is the follow com, but I modify it by putting it medium magnet. So I modify it by putting it. Let me put this magnet, one of these, out so that you guys will see what I'm talking about. You can see. So I when I remove this rotor out, when I remove this magnet out, there is no current output, which means without this magnet, this generator will not give current because it is a self-exciter. So magnets have to be there, and stronger magnet will result stronger excitation. So which means it will give more output. So see the original magnet. This is the ceramic magnet. It's not much strong. You can see this is the original ceramic magnet. If you go back to watch my previous video, we see where I pulled it off. So I replace it with this neodymium magnet. It's very strong neodymium magnet. Very strong neodymium magnet. So let me put it back. You can see. So now I'm gonna couple it back. I'm gonna couple it back. I'm gonna couple it back. Let me so that you see it. You see. Then this is the center load. This is the center load. So you have to tighten it so that it will fit very well. Then this is the, you can see this dot. So you have to make sure that it tallies with here. You can see. So you have to enter here. So you have to set the bearing. Let me set it this way. Yeah. Yes, it has entered. So and when you can see here now, so both of them face opposite, so that your system, you can see the armature generator is rotating freely. So let me tighten it. Don't tighten it much because the everything is already stationed and very perfect. You can see here. So if you check here is where I tied it from the on the frame. So now let me shift this. Let me shift it. So if you look at here, this is my DC motor. So this motor is a 12-volt brushless motor. If you watch my previous video, I've already demonstrated it with brush and brushless motor. So I've already done the experiment. So I'm gonna couple it. I'm gonna couple it. So you can see how I structured the city. So you can see. So here we go to the generator side. So let me couple the motor first of all. It's very easy. See, it's very easy to couple these two sides. So let me tight it very well. Let me lock it. So now I have tied the motor very okay. So you can see very strong, very strong. So now this is the generator. So these two we I will lock it here. I will lock it here. And another thing, you can see this is the where the generator stand with. So let me tight it. You can see. It's imperfect. This generator has a 4 terminal. This yellow wire is for capacitor, while this red wire is for 220 mains. So if you look at here, you will see damper here. You will see damper here. I just put it. Though there is no vibration from the generator, but I just decided to put it. Remember, we have to tight. Have to tight here. So I have to tight here. Oh. So now everything is okay now. Everything is still perfect. So this is my capacitor 24 UF. So let me connect it because it is a self-induction generator. Without capacitor, it won't give any current. So if you look closely here, you will see this is my charger. I have experiments with this charger. I have in my previous video, I have experimented with this charger. This charger is a good charger. It is the reason why I like this charger is because it has a current selector. You can set from 4 amp, 8 amp, 12 amp, and 20 amp. That is it. That is one of the reasons why I like this charger. But even though I find this very interesting and very portable, this is a SWA. I think the same product. I think so. This one is a smart fast charger. It is a this is the model. It's very portable. So very portable. It's like twice of this size. So very portable. It is a 10 amp plus. So very portable. So it is a Chinese. So you can see it. The input voltage is from 150 volt to 250 volts, 50-60 hertz. So the charging voltage is 14.5 volts. Charging current is 10 amp mass. So you can see it. It's very portable. But this one it doesn't has any button. just automatically. So even though your battery charger require 20 amp, all we get here is a 10 amp. So it doesn't have any button, doesn't have any current selector or any switch. So just direct. So I prefer this due to the size and portable and how smart it is. So I'm gonna run this test with this charger. So not this one. So I'm gonna run it with this charger. So this is my 12-volt battery, 12-volt battery, deep cycle battery, 7 amp, 12-volt 7 amp. So let me first of all check the voltage. And when you want to do this project, make sure that you charge your battery full charge. Make sure that you charge your battery fully, so that when you're doing the system, you know where you are making error. It will be very, very easy for you to detect. So don't use a half charge battery. So you can see 12.9, which means the battery is fully charged. Let me switch it to AC. So this is the my load that we test it with. So let me go back. So you can see how I couple the system. This is experimental, and it's like I have tested the system with this previous charger. I have tested it with the previous charger, and from my observation, I like this charger. I like it. I like the portable, and it's very, very okay. This one is okay, but due to my I'm trying harder so that the current consumption from this motor will be below. I don't need 20 amp, because charging with it this 20 amp, I don't think this generator can handle it. I don't think the generator can handle it, because there will be a lot of drag. When you take more current from the generator, there will be more drag. So I'm trying to lower the current consumption, the power consumption, energy consumption from the generator. So I find it not needable to use this charger. So this 10 amp, I find it okay. I find it okay. So my previous, I use this charger. So but I want to use this charger. I want to know if the energy from this generator will be charging the battery, this 12-volt battery. So I have explained how I did my alignment. So if you can check the system, the previous image, I put this medium magnet. I put this medium magnet, very, very strong, very, very strong medium magnet. So I'm gonna run the system to know if there is any output energy. So I'm gonna connect my bulb. It's supposed to have a this thing here, but let me run it manual. So let me bring this 12 volts here. So remember, this motor is a brushless motor. So when you want to run it, make sure that the positive terminal goes to the positive terminal of the battery. You can see, let me turn it around. You can see the red sign is positive, while the black sign is negative. So it also with a cable, you can see the red is for the positive, while the black is for the negative. So because when you can change when you put it this way, the motor is gone. It is not a brush motor, it is brushless motor, which means it goes one, okay, it go only one direction. So I have connected the motor. So when you connect the motor, it takes about some seconds, few seconds before it rotates. It doesn't rotate immediately like brush motor. So I have to have a switch here, but just pardon me for that. Oh, the terminal have pulled out. So let's know if there is output current from here. So there's output current here. There's output current here. You can see it's red shining bright. There's output current here. So now, what I'm gonna do now, what I'm gonna do now is I will run the system. I will put the charger to see if the system will continue working and charging. I will connect the charger here to see if the system will continue charging and see how the system is running perfectly. And see how it's running perfectly. So so it showed that there is output. It showed that there is output from this generator. So now I'm gonna connect the charger here. I'm gonna connect the charger, then reverse the current back to the battery. Instead of running this bulb, I'm gonna use the energy, then reverse it uh, to this battery. So that's what I'm gonna do now. So I have to make the connection. I'm supposed to have the socket here and the extension, but I will do it manually. So let me dismantle the bulb. So I have dismantled the bulb. So now I'm gonna the terminal of the charger. So let me run it and isolate it to avoid short circuit. So it's very very important to avoid short circuit. So let's see. So I'm gonna um connect the terminal to the generator. Let me connect it. So let me put this cover out from the battery. 7 amp. So now this is the battery. So now I'm gonna run the system again. This is my charger. So let me connect it. The red positive will go to the red terminal of the battery. You can even see the plus minus. So be careful. This motor is brushless. So now let me run the motor again and connect my meter and connect my bulb again. It's pulling out. The motor take a while and it starts. So you can see there is output. So now I'm gonna connect the terminal of the battery charger. So the energy need to run this bulb. I'm gonna use it to charge the battery, like self-charging. Okay, now this charger, I'm gonna connect the second terminal, which is black, positive, negative. So let me disconnect this motor terminal. So now you can see there is a reading here. You can see there is a reading here. The battery is 100%, then it's 12.8. It is not showing any current here because there is no any current draw from the battery. So it maintain 100% 12.8 volts. So which indicate that the battery is fully charged. So now I'm gonna connect the negative terminal of the battery. Remember, it is now like the output current from this generator. I'm now using it to recharge this battery. So let me connect. The fan is turning, the fan is blowing, so which means there is a return of energy. There is a return of energy. The indicator is blinking. The indicator, which means it is charging. I see the air from this armature fan, so it's blowing. So the system is charging, but there is a room for improvement. There's a room for improvement. So see it. The fan is still on, which means the system is charging. The there's a can see the battery is showing 12 point 12 point I think 12.2. So which means there is little drop of voltage. So which means that the power the motor is consuming is a little bit bigger than the returning energy. Understand? The power the motor is consuming is like a little bit the incoming power at the returning energy. So which means what the system need now is balancing. So when we balance the energy, it will be continuous running. It will be continuous running. So when we balance, what the system need now is balance. So when we balance the system, it will be recycling. So you can see the noise from the so due to much energy draw. You can see here is a 12 amp. It's 12 amp. This indicator is like the battery is charging. So thank you for watching.